أخبار المركز الجامعي نور البشير البيض.
First of all, I would like to warmly thank you for your attendance. I would also express my gratitude to the organizer of the National Competition of AI of the University Center of El-bayadh. Thank you for the invitation and for giving me the opportunity to present one of my works today with you. My gratitude also my special thanks goes to Mr. Benjilali for the invitation, Mr. Tayyib Faraj, the director of the University of El-bayadh, and also Wali of El-bayadh, Mr. Balaribi. My name is Abeer Afane. I hold a Ph.D. in computer science, and my works focus on image processing and AI and medical image processing. I'm originally from El-bayadh, and I lived in Tindouf before, and my mom is from Algiers, so I'm so proud to be a part of this event today. Currently, I'm a postdoc at INRIA Sophia Antipolis in the south of France. I work on the optimization of the generative models using some black box optimization methods. Today, I'm thrilled to share with you one of the work and the project I worked on during my PhD, which focused on the segmentation of liver vessels using some topological deep learning on 3D medical images. So I will be starting this presentation with an introduction where I will explain more deeply the general context of the presentation. As you know that the liver is the largest organ in the body, and it is a vital part of the digestive system. It has a unique vascular system that plays an essential role in its function. The liver has a very complex, as you can see, a very complex vascular structures, and the analysis of this shape and the topology of these structures can help radiologists in their analysis, in their interpretation. And this is why today, the problem that I present to you today focus on the segmentation of liver vessel and the importance of segmentation for clinical application and the role of deep images and liver vessel in CT scan images. As you can see that the liver vessel here, visualization images, but for the tumors it's the MRI is the best way to use to extract the tumors or the cancer of the liver. So today it's very important to develop a model that can segment the liver vessel in MRI images but also in CT scan images to extract the tumors. So why the deep learning? Because the AI stands out for its ability to process and analyze a large amount of data. And for example, using the mammograph images and convolutional neural network can provide a solution to analyze medical images and to extract liver vessel without using any further treatment. As you can see in this representation, that the use of deep learning methods increase or evolve very fast and rapidly from 2012 to 2019. We passed from 1,000 publications in medical field to 5,000 in 2019. And this is because this algorithm can facilitate the work of clinicians and radiologists in diagnosis, in defining a treatment, and in different modalities such as MRI, CT scan, and for different tasks such as the segmentation, the classification, and object detection. And on different organs and structures such as the liver, the lung, and the brain, and the vessel. So, among the essential activities of radiologists is, first of all, this visualization of structures and organs, such as the liver and the vessels, the tumors identification, and the defining a treatment using medical knowledge. But due to the large amount of data, the analysis of this data is very difficult, and special on the small regions such as the vessel. And this is why the biomedical engineers or AI scientists interfere to facilitate the work by developing algorithms for data analysis and for automatically detect the liver vessel, the organs, and the tumors. But all these experts need the radiologists and specialists knowledge to validate their algorithm, because it's not possible to work only AI scientists with data. We need always doctors, radiologists, clinicians to validate our work. So from all this we can deduce that the effort, the collective effort, is very important to define the most suitable treatment to a patient and to facilitate the life of clinician and patient also. So this is the main model used in AI for segmentation of medical images. At the unit, which is constituted of two blocks, the encoder block, which is similar to CNN that we use for classification, that extract in images very relevant information, such as the color, the form, and which is concatenated with the second part, which is the decoder that analyzes the image and give the output in the form of an image and a good segmentation. This algorithm were developed the first time to analyze the medical images, and then they use it now in other fields for segmentation problem, and especially semantic segmentation tasks. I talked before about the topological deep learning. So what is the topological deep learning? It's all the neural network that analyze or can deal with only with graphs for example, complex data representation, for node classification, because we have the graphs. The graph is composed of nodes and links. So the links prediction, but in medical field, this architecture weren't used in any case, especially for the segmentation of liver vessel, which has a very complex, very complex structures. So this will be the outline I will be going through as the presentation progress. So I will talk about the objective